Now, what do you think will happen if I take the diffraction grating and put it into the laser beam? Well, I'm sure you expected that. A row of diffraction maxima on the screen, bright spots, and remember, of course, that the spacing between those spots depends upon the wavelength. Notice also that if I tilt the grating one way or the other way, the pattern also changes its orientation. Now, I can take another grating, just the same as the first one, stick the two together at right angles to each other, so as to make a two-dimensional diffraction grating. And now what do you expect to see? Well, get it nicely in the beam. Yeah, there we are. Well, a two-dimensional diffraction pattern. And the orientation of the pattern, again, of course, corresponds to the orientation of the two-dimensional grating. Now, naturally, we could extend this idea to 3 dimensions, and then we'd be simulating a 3-dimensional periodic structure, rather like the sort of thing you get with a crystal, in which the atoms are arranged in a regularly repeating pattern in 3 dimensions. Now, if instead of having just a single orientation like that of a 2-dimensional grating, what do you think would happen if we had not just one orientation, but lots and lots and lots of them with all different random orientations, like that? Well, let's see if we can show what would happen. Okay, what I've got here is 2 gratings crossed over each other just as I had before, except I've put them on this little disc, you see, which can rotate. And as it rotates, of course, the 2 gratings take up every possible position, and so the spots, the pattern on the screen, can take up a whole lot of different positions. And if I switch this little motor on, yeah, now I think if we just take the lights down a little bit, you'll be able to see that a bit more clearly. Well, there you are. Isn't that beautiful? Now, remember that the spacing between the spots depends on the wavelength, and so also the radius of these diffraction rings, which are made up of the spots, will depend upon the wavelength.